Okay, so in this lecture, we're going to look at classless addresses and the classless interdomain routing system, or CIDR, CIDR. So let's go ahead and take a peek. Okay, classless addressing and CIDR. Classless addressing, or CIDR, is an addressing scheme using variable length subnet mask, which basically it's the slash number that you see after some IP addresses. And basically what it does, it replaces the subnet mask, and it's not very difficult to figure out. We'll talk about it a little bit more in detail. But just know that right now it determines what the subnet mask is and tells you without having to put it down. A variable length subnet mask is a subnet designed using multiple masks of the same network. So you're subnetting basically is what you're doing. You're breaking the network up into parts, and each one of those parts is going to have a different subnet mask. What it does, it conserves IP addresses, provided basically it's a stopgap for transitioning to IPv6. It provides flexibility. You can create networks based on best suited for business, whatever the business needs. If you've got a section that needs a lot more and a section that needs a lot less, and you don't want to have two routers, you can do this with subnetting. And classless addresses enables the creation of IP blocks tailored to the organization. Once again, you're building segments in order to help control traffic and cut down on choke points. And then allows network devices to be separated into different networks. This provides for another layer of security. Without some work in the router, these subnets can't talk to each other. So there you go. All right, CIDR notation. Basically, you've got a subnet mask here, 192.168. A subnet mask here, 255.255.255.0. IP address here, 192.168.1.12. And so if you set this into binary, 155 is going to be 8 ones, and 0 is going to be 8 zeros. And so if you count the number of network bits, pardon me. If you count the number of network bits, 8, 16, 24, that tells you that you've got the full amount of network bits and the full amount of host bits for this type of address. And so your CIDR notation then would be 192.168.1.12/24. And the 24 comes from these 24 parts of the network, or 24 bits of the network portion of the address, or of the subnet mask. If this were 255.255.0.0, then instead of being /24, this would be /16. If this were a class A, what we consider a class A address, and so it'd be 255.0.0.0, then the slash would be /8, because there's only 8 ones in the subnet mask, and all the rest are zeros. And so that's how we get this number. And then when we start subnetting, this number can be different. We'll see what happens when we start subnetting, and maybe we'll have 4 ones down here and 4 zeros. So we're actually making a smaller subnet mask. So when that happens, then you'd have 24, 25, 26, 27, 28. So if we had 4 zeros here and these 4 ones, this would be /28, because we have 3 times 8 is 24 plus 4 is 28. So the CIDR notation's original IP address / and the number of bits used in the subnet mask for the network portion. So this is basically a CIDR address table. And if we look at the subnet mask, we can tell what the number following the slash is going to be by the number of network bits. So if we have 32 host bits, that means we have no network bits. That's when we get a /0 in this one. 0, 0, 0, 0. There's no ones here. And so you're going to have 32 host bits. You're going to have no network bits. Of course, you got a lot of possible IP addresses, 2 to the 32nd power, but you also have no network identification. /1, basically, you got the same thing. 31 host bits, which means you only have 1 network bit. This first digit up here would be a network bit if this were converted into binary. So 128 converted to binary is going to leave you all the rest of these as zeros. So you're going to have 31 host bits. That means almost everything's going to be a host bit. Same thing here, 192.0.0.0, 30 host bits, only 2 network bits. /3, basically 29 host bits, only 3 network bits. So you got 3 network bits to identify the network. /4, that's going to leave you 28 host bits. The resulting subnet mask will be 240.0.0.0. Okay, let's get down here to /8. So 255, that's going to be 8 ones. So you've got these 8 ones counted for the network bit. Everything else is a 0. So you've got 8, 16, 24 host bits. 9, you've got 255.192. So you've got 22 host bits. That means you've got 10. 32 minus 22 is 10. You've got 10 network bits. So essentially what this / does, it tells you the number of network bits that you have. And we'll go over this a little more in detail when we practice it for homework. But you get the idea. You can use this table to figure out what your / number would be based on what your subnet mask is. And it goes all the way down to /32, which is 255.255, which means you have 0 host bits. That means you can't put any devices on this network. So it's all network bits and no host bits. The way that we calculate that, so we've got 196.10.1.12. That's the IP address, 255.255.255.0. So this would be, as it stands right now, that would be a /24 because you've got 24 network bits and only 8 host bits. So that would be /24. If we look at our deal back up here, we say /24. That means we've got 255.255.255, and that means we've got 8 host bits, just like we figured. 24-bit network portion, 8-bit. So now if we change that and we want to borrow some network, or we want to borrow some bits to go into the network, then we're going to have the first 24, just like we expected, but we're going to change these 3 into network bits. Now what that does, that leaves us less host bits to work with. So we're actually making the network smaller. So we're dividing it up into a subnet. Now the host bits, there's only 5 of them, which means that we can only have 2 to the 5th instead of 2 to the 8th. If you look up here we had 2 to the 8th. We could have 254 devices on the network. Well, now we can only have basically what amounts to 27/27. Now we can only have 2 to the 5th, which is 32. We've really reduced the size of our network. And that's 2 to the 5th, yep. 30, because we lose 2 for the 2 addresses that we have to sacrifice. So we only can have 30 addresses. And the CIDR notation would be 196.10.1.12/27. Remember, we went from 24, we borrowed 3, 24, 25, 26, 27. So this is how you would subnet a regular Class C address, or a regular 255.255.255.0 subnet mask. So we want to make the network smaller. We're going to divide the network up into pieces. So now we're going to take 3 of these bits and we're going to make them network bits. Now, is that going to affect connectivity? Yes, it is, because the subnet mask is no longer the same. And so anything that was on this network, if it's got the same 255.255.255.0 subnet mask, it's not going to connect. So this is going to change connectivity. This is how we control traffic on a network when we subnet it. Subnet mask is converted to binary. 254 host addresses are available. And to create more subnets, we have 3 host segments. We borrow those 3 and add them to the network segment. the CIDR notation, we went from 24, we borrowed those 3, that gives us 27. It also reduces the number of computers or devices we can put on the network. Got a challenge activity here, and once you've completed that, then you should be done with this. This is a little confusing, so if you have problems with it, let me know. Okay, guys, like I said, it's a little confusing. If you're not completely comfortable with it after you've completed the challenge activities and the participation activities. Once you've completed those, if you still have issues, send me a message through the Canvas inbox or contact me in class, and we'll go over that material, because like I said, it's not the simplest thing in the world. You got to remember what's network bits and what's host bits, and when we start borrowing, you got to wonder why we would do that. So if you have questions, let me know, and I'll do my best to answer them. Have a good day.